In lesson 3-4, you're going to be working on equivalent fractions. The main focus in this is for you to color fraction circles and find missing numerators, for you to look for number patterns in and learn a rule for generating equivalent fractions, for you to be able to generate equivalent fractions with the denominators of 10 and 100, and for you also to be able to apply and analyze the equivalent fractions rule to generate equivalent fractions. But let's go ahead like every other lesson and let's start out with our mental math and fluency. Find multiples of 2 starting with 16. So remember, that's our first number is 16, and then we're going to go up by 2. So 16 should be our first number, then 18, then 20, then 22, then 24, then 26. So if I know 2 times 8 is 16, I'm also going to figure out the pattern that 2 times 9 is 18, and 2 times 10 is 20, and 2 times 11 is 22. 2 times 12 is 24, and 2 times 13 is 26. So now let's find multiples of 5, starting with 45. So my first number should be 45, and I'm going up by 5. So 45, 50, 55, 60, 65, 70. 5 times 9 is 45. 5 times 10 is 50. 5 times 11 is 55. 5 times 12 is 60. 5 times 13 is 65. And 5 times 14 is 70. Always look for those patterns when looking for multiples of number. I want you to do Math Journal page 77, where it's talking about equivalent names for fractions. I want you to be able to share your observations when you come back to me about the circles that you've colored in on journal page 77. And remember to include this following observation. As you move from left to right, do the number of parts increase and the sides apart, or do they decrease? And how are the fractions still the same? So again, it says color the circles and enter the missing numerators. The numerators are the numbers on top. If you look, that's where the boxes are empty. So if I want to color half of this circle, well, I'm going to color half of this circle. So I'd probably color in this. That's half. How many pieces was that? Well, it was 3. But look at this neat little trick. If I take the denominator, the number down on the bottom, and I say, how did 2 become 6? And I go, oh, times 3, I would do the same thing to the top number. I would multiply by 3. What's 1 times 3? 3. Oh, I know that makes them an equivalent fraction. Again, if I want to color half of the circle, I'd color this half. I could count the pieces. 1, 2, 3, 4, 5, 6. That's my numerator. I got 6 out of 12 colored. Or again, I could ask myself, how does 2 become 12? Well, this time, I'm noticing that it's times 6. So instead of times 3, I do times 6. And whatever I do to the denominator, I do to the numerator. So 2 times 6 is 12, and 1 times 6 is 6. They are equivalent. The whole always remains the same. It doesn't matter where you color the same equal parts of each circle as long as they color the same number of equal parts. Finish this page, then bring it up to me so that I can check it for you. Pause the tape now and please do that. So, problem 1. 1 times 3 was 3. 2 times 3 was 6. Again, 1 times 6 was 6. 2 times 6 was 12. Just repeating what I just had you do. All right, so now you're looking at different denominators from 10 to 100. Using what I just showed you, how has 10 become 100? Hopefully you've already figured out, well, what I'm going to do is I'm going to write times 10. Well, whatever I do to the bottom, I do to the top, the numerator. So 6 times 10 is 60. Again, 10 and 7 and 70. Well, this just looks a little bit different than that, but really you're doing the same thing. You're asking yourself, how did the numerator 7 become 70? Well, again, all you simply did was times it by 10. So whatever I do to the numerator, I do to the denominator. So what's 10 times 10? 100. Ten times what equals 100? Again, I start with the bottom number because that's what information I have. The denominator is telling me that I multiply by 10, so I must do the same to the numerator. 14 times 10 is 140. And the final one, 20 became 200 how? Well, I multiplied it by 10. 20 times 10 is 200, so 10 times 10 equals 100. Now I know that my fractions are equivalent. So in the name collection box, you are going to write the missing number in each fraction so that the fraction belongs in the box. And then you're going to fill in the empty boxes with fractions that belong. For this, you're going to go to Math Journal, page 78. Pause the recording now and please turn to that page, and then I will help you to get started. All right, you should be to Math Journal, page 78, and let's take a look at this. My denominator says, or my problem says, that I want everything in these boxes to equal a half. Well, if my denominator is 4 here, but it was originally 2 here, how did 2 become a 4? Times 2. So what's 1 times 2? 2. Look at my top number is half of my bottom number. So 1/2 equals 2/4. Now this time I'm looking at the numerator, the number on top. How did 1 become 5 times 5? So what's 2 times 5? 10. Once again, my top number 5 is half of my denominator 10, so that also equals half. Please finish this name collection box on page 78 and then bring it back to me so that I know for sure that you understand what you're doing. Pause the tape now and complete this page. This is what it looks like on page 78. Pause the tape. There were the first initial answers. So the equivalent fraction rule. A over B equals N times A and then the number times B. That's exactly what we did, only now we're using a variable to explain it instead of actual numbers. So an equivalent fractions rule. This is Math Masters, page 111. You're going to need to come back to me to get that, and I will give it to you. This is showing me that you understand what you're doing. It reads, Margaret says the value of a fraction does not change if you do the same thing to the numerator and denominator. She says that she added 2 to the numerator and denominator in 1/4 and got 3/6. She says, therefore, 1/4 equals 3/6. How can you tell or show Margaret that she is wrong? So look at the numbers and think about what we've done in the past. If you really check it and you really look at it, you need to be asking yourself, did the process that she used here, is that the process that we used before? Pause the tape now, look back and rewind if you need to, and ask yourself, did we add or what did we do to explain your answer? And again, that was the answer. You should have checked in with me by now. And we're moving forward. It says, estimate and write a number model to show your work. Solve the multi-step number story. Remember, multi-step just means more than one step. So for this, you're going to go back into your math journal to page 79. And I'm going to help you with this first one. So each day, a company delivers newspapers to the town of Wayland. It has 158 customers on the north side of town, 378 customers on the west side, and 237 customers on the south side. The company receives 900 newspapers to deliver. How many will be left over? Well, the first thing you want to do when it says to estimate is you want to round. So let's round to the hundreds place. 158 would round to 200. $378 would round to 400. $237, well, 3 is less than 5, so we're going to round that down to 200. That equals 800. It says the company receives 900 newspapers to deliver. How many will be left over in our estimate? Well, I got to take that 900, and I'm sorry about that. I just made that a equal sign says subtraction, minus the 800 equals 100. So my answer of my estimate is 800. Again, this time my number model would be, well, I have exactly 900, but I'm going to be subtracting the 158 plus the 378 plus the 237. That's going to equal the answer. So remember, what I'm going to do is I'm going to add these together. Whatever that answer is, I'm going to subtract that from the 900 to get my answer. Finish this page. When you've completed it, bring it back to me, and I will double check it for you. So pause the recording now and do that, please. Again, this is just showing you Math Journal page 79. You need to pause the recording now to finish that page, and then don't forget to bring it back to me. That was the answer, but I should have already checked that for you. The next one is looking at Math Journal page 80. It reads, a rectangular fish tank holds 12 fish. A round fish bowl holds 3 fish. How many times as many fish does the rectangular tank hold as the round bowl? Well, again, the rectangular fish holds 12 fish. A round fish bowl holds 3 fish. How many times as many fish? Times as many fish. Does the rectangular tank hold as a round bowl? Your equation with the unknown would look like this. And then your answer needs to go here. Pause the recording now, finish Math Journal page 80, and then bring it up to me when you get finished. Again, this is just showing you what the Math Journal page looks like. You should have paused the tape until I have checked it. There is the answer key, which I should have done for you. And then it says, fill in the boxes to complete the equivalent fractions. This is Math Masters, page 114. You're going to have to come get it from me, finish this page, and then bring it back to me so that I know that you're understanding what you're doing. And I will give you directions from there.